Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Grignard reagents, RMgX, act as nucleophiles, adding to electrophilic carbonyl carbons, aldehydes, ketones, or epoxides to give alcohols after aqueous acid workup. The type of alcohol produced depends on the substrate A. Moving on to the next step. PCC, pyridinium chlorochromate, in dichloromethane oxidize primary alcohols to aldehydes and secondary alcohols to ketones, but does not react with tertiary alcohols. Since compound B does not react with PCC, B must be a tertiary alcohol. Moving on to the next step. Grignard addition to a ketone gives a tertiary alcohol. When CH3CH2NGI, ethyl Grignard, adds to a ketone, the ethyl group adds to the carbonyl carbon, which already bears two carbon substituents, yielding a tertiary alcohol after protonation. And for the final step, substance A is equal to CH3CH2C is equal to O, CH3, methyl ethyl ketone, butanone. The Grignard, CH3CH2 attacks the carbonyl carbon of CH3CH2C is equal to O, CH3, giving the alkoxide CH3CH2C, O-, CH2CH3, CH3 after addition, then protonation gives CH3CH2C, of CH2CH3, CH3 is equal to 3-methyl-3-pentanol, a tertiary alcohol. This tertiary alcohol cannot be oxidized by PCC. This matches the condition. A. CH3CHO, acetaldehyde, is an aldehyde. Grignard addition gives a secondary alcohol, CH3CH, of CH2CH3, which PCC can oxidize to a ketone. Fails the test. CH2C is equal to O, formaldehyde, gives a primary alcohol, CH3CH2CH2O, after Grignard addition, which PCC oxidizes to an aldehyde. Fails the test. D. Ethylene oxide gives a primary alcohol, CH3CH2CH2CH2O after ring opening, oxidizable by PCC. Fails the test. Only option B, a ketone, produces a tertiary alcohol with the ethyl Grignard, consistent with no reaction with PCC. Therefore, the correct answer is B. Therefore, the correct answer is option B.